When you hear the term sound barrier, what pops into your head? Probably some kind of violent shudder, maybe a literal wall in the sky, right? Well, it's one of the most famous ideas in aviation, but it's also one of the most misunderstood. So today, let's really separate the myth from the reality.
So let's just get right to it. What is it actually like for the pilot? The person sitting in the cockpit as their aircraft punches through Mach 1 and goes supersonic. What do they feel? What do they hear? Well, believe it or not, a supersonic pilot on Reddit was asked that exact question. And his answer was, well, it was incredibly blunt and pretty surprising. His words, abso-fucking-ly-nothing. So how? How can one of the most dramatic events in flight be a complete non-event for the person at the controls? That's what we're going to break down. To get why it feels like nothing, we first have to tackle the popular myth, this idea of what the sound barrier is supposed to be. For decades, people imagined it as something very, very literal. I mean, you got to put yourself in their shoes. Early aviators pushing the limits of speed, they genuinely feared they were flying towards an invisible physical wall, an aerodynamic barrier that, if you hit it wrong, would just shatter your aircraft into a million pieces. And you know what? In a way, their fears were justified because something very real and very dangerous was happening to their planes. So, okay, the barrier wasn't a wall, but man, it was an unseen force of nature. Back in the 1940s, engineers and test pilots were locked in this desperate race to understand and overcome the incredibly violent effects of just approaching the speed of sound. These were the demons that created the myth in the first place. See, in the transonic range, that's the tricky zone just below and above Mach 1, pilots would hit this sudden, massive spike in drag. Their planes would shake uncontrollably, pitch up and down violently, and often they'd lose all control, leading to catastrophic failure. So yeah, the consequences of the barrier were terrifyingly real. The solution wasn't just about more power, it was about smarter design. A NASA engineer named Richard Whitcomb came up with what's called the area rule. By carefully shaping the aircraft, giving it this kind of Coke bottle waist, engineers could drastically cut down on this dangerous wave drag. And you can see the results right here. They weren't trying to break through a wall, they were designing a key to unlock it. Okay, so if there isn't a wall to break, what in the world is the sonic boom? Well, the best way to think about it isn't some big explosion. It's more like a wake, just like the one a boat leaves in the water. So think about it. Every object moving through the air creates pressure waves. That's sound. At normal, subsonic speeds, those waves ripple out ahead of the plane, no problem. But when that aircraft reaches the speed of sound, it literally catches up to its own noise. The pressure waves just can't get out of the way fast enough. So what happens next? Well, the aircraft is now outrunning its own sound waves. They can't escape, so they're forced to pile up on top of each other. This creates a massive cone-shaped shockwave of compressed air that trails behind the jet. And when that cone of pressure washes over you on the ground, that's the boom. And hey, this wasn't just some theory on a chalkboard. Using a really cool technique called Schlierian photography, scientists could actually see these invisible forces at work. They proved these powerful shockwaves were very, very real. And sometimes you don't need any special equipment to see it. If the air is humid enough, the extreme drop in pressure and temperature inside that shock cone can cause water vapor to instantly condense into a cloud. This beautiful vapor cone you're looking at, that's the sound barrier making itself visible. It's spectacular. So we've got the science and we've got the engineering. But who was the first person to put it all together and prove it could actually be done? Well, that brings us to the incredible story of Chuck Yeager and the Bell X-1. This whole thing didn't just happen overnight. The X-1 program was a dedicated research project with one single goal: fly faster than sound. It started back in '44, and after years of testing and glide flights, the team was finally ready to make history in October of 1947. And here they are, Air Force Captain Chuck Yeager and the Bell X-1 rocket plane. He nicknamed it Glamorous Glennis after his wife. Now, the design team knew that brute force alone wasn't the answer, so they brilliantly shaped the X-1 like a .50 caliber bullet, because that's a projectile they knew was perfectly stable at supersonic speeds. But the plane's cool shape wasn't its only trick. Nope, it had a secret weapon that solved the single biggest problem of transonic flight: control. So get this. On a flight just before his record-breaking one, Yeager hit Mach 0.94 and suddenly lost all pitch control. A shock wave had formed on the tail, making the normal control surfaces, the elevators, completely useless. This was the wall. But the X-1's designers had seen this coming. The entire horizontal tail could be tilted up or down. By using this all-moving tailplane, Yeager could literally muscle through the shockwave's effects and regain control. That was the final key to the puzzle.
Which brings us full circle. On October 14, 1947, Chuck Yeager climbed into the X-1, dropped from the bomb bay of a B-29, and fired up his rocket engine, armed with all the knowledge and all the technology to finally fly supersonic.
Now, the myth promised this violent struggle, right? A deafening crack as he smashed through an invisible barrier. But the reality for Yeager in that cockpit, it was completely smooth. The only way he knew he had broken the sound barrier was by looking at the Mach meter on his dashboard as it ticked quietly from 0.99 past 1.0. The massive sonic boom, the whole spectacle, was all happening miles behind him. It was an event he would never, ever hear or feel.
So, in the end, the sonic boom is an event for us, the people on the ground, not for the pilot. The real goal was never to break some kind of barrier, it was just to outrun our own sound. Which leaves us with a really fascinating modern question. After all these years of making a big boom, can we finally learn to fly supersonic? Quietly?